Hello, my name is Adelaide Goodrich, and I will be talking about the effects of warming temperatures and carbon dioxide levels on lakes. Often when talking about warming temperatures and the effects it has on water, we tend to focus a lot on oceans, but lakes also are impacted and play a vital role when it comes to climate. Lakes are an important ecosystem itself, and it helps other ecosystems to function. Lakes, especially the Great Lakes, can be a major source of freshwater storage. They can also help to replenish groundwater supplies and also can be a source of drinking water. There are tropical or saltwater lakes, so those kinds of lakes don't necessarily have these same kind of roles, but they are still important in their function and also are often overlooked in the discussion of water and climate change. Some lakes experience lake turnover or vertical circulation. This is when the less dense, warmer layer of water on top in the epimylium layer mixes with the denser, older layer of water on the bottom, the hypomylium layer. The concentration of dissolved substances can also impact the density of the water. But this mixing of the epimylium and the hypomylium layer helps to balance out the temperature of water and also is important for distributing nutrients and oxygen levels throughout the water. There are some lakes that do not overturn and are permanently stratified, and this tends to affect how oxygen and other nutrients are distributed throughout the water. Multiple factors determine whether a lake experiences vertical circulation, like wind, wave currents, depth, size, etc. So this equation on the slide was pulled from one of the papers that I'll be discussing a little bit later, but ultimately it's kind of saying if there is increasing incoming radiation, then there should be more radiation outgoing, an equal amount. So in this equation, just to break it down, the absorbed solar, the S, plus the incoming long wave radiation, or the LIN, is set equal to the outgoing long wave radiation, the L out, plus the latent heat, the E, plus the sensible heat, the H, plus the average heat gain, the FS. With this being said, deeper lakes tend to retain heat because their outgoing radiation is smaller than the incoming radiation. So in order to balance the equation, it tends to have a higher heat gain, so a higher FS. Shallower lakes tend to be quicker in reaching the equilibrium shown in the equation, so they tend to have a lower heat gain or a lower FS. One study that looked at Lake Tanganyika in Africa found that increasing temperatures may impact vertical circulation. The warming surface waters and the evaporation of the epimylium layer, again that's the top layer, may cause the hypomylium layer, which is the bottom layer, to increase in temperature with the downward diffusion of heat. With increased temperatures, the lakes are absorbing more long-wave radiation. The study looked at temperature gains in the lakes at different depths for different time periods. Over the course of a century, the temperature increased and the percentage of heat gain increased at all depths. The graph on the left was made using Schmidt's stability equation, which calculates the ratio of viscous diffusion rate to mass diffusion rate, which ultimately determines the lake's ability to mix or stratify. As we have seen, increased carbon dioxide levels tend to mean increased temperatures. We've seen this throughout the course. One study looked at how various carbon dioxide levels would impact different fish species and their habitats in Wisconsin lakes. A DYR-ESM model was used and different conditions were put into the model to determine the effect of 1 times the current carbon dioxide levels and 2 times the current carbon dioxide levels and how they would impact different variables, such as the fish habitats. The researchers looked at different factors like air temperature, water temperature, wind speed, precipitation, solar radiation, humidity, turnover depth, the seasons, ice melt and formation, cloud cover, among others. So sometimes different species can be used to help determine the effects of different factors, like temperature and/or carbon dioxide levels. For example, fish can help determine the different conditions in bodies of water since different species tend to need different levels of nutrients, oxygen levels, and survive better at particular temperatures. 4 different fish species and their habitats were observed in the study on Wisconsin lakes with interest in the different temperatures where these fish species tend to reside. The lake trout was chosen for the cold water since it resides in water around 10 degrees Celsius. The Cisco and yellow perch was chosen for the intermediate water temperature levels with preference of 15.8 degrees Celsius and 23 degrees Celsius respectively. The largemouth bass was chosen as the fish that resided in the warmer water with a preferred temperature being 27.5 degrees Celsius. The graphs show how the volume of lake trout and the Cisco fish habitats respond to the different carbon dioxide levels. The study found that increased carbon dioxide levels would lead to changes in the thermal habitat of fish due to the overall warming of the water. This warming led to changes in oxygen levels, and where different food sources such as plankton, in the study the Daphnia plankton was observed, and where these could survive. This caused fish to change their range in the lakes in order to get to the different food sources and to the different temperatures. The changes in fish ranges and other species like the plankton should be taken as a concern because some species may be forced out of their preferred habitat, causing their populations to decrease. Also, if a lake that has experienced turnover starts to have a smaller range of temperatures and/or less oxygen, then the species that reside at depths that rely on that mixing of nutrients or temperatures and oxygen levels could likely experience decreased populations. So for those studying how carbon dioxide and temperatures impact lakes, those researchers in the field, many have expressed concern for how climate change and warming temperatures would impact lakes and the basic functions of lakes. Lakes will likely be impacted by changes in vertical circulation, like I've gone over. Lakes also may be impacted by different changes in concentration of minerals like salinity in saltwater lakes. Also, aquatic species will be impacted due to changes in temperatures, oxygen levels, and other changes. We kind of saw this with the fish population in the Wisconsin lakes, and so these changes may cause some of these populations to decline. Invasive species may also thrive in lakes with increased carbon dioxide levels and temperatures because they might move into an area where they have no predators, but also into favorable conditions for themselves. Photosynthesis of aquatic plants like algae will be impacted by the changes in solar radiation and greenhouse effect. Those changes in water temperature and carbon dioxide levels will also impact the photosynthesis process. Obviously, ice formation and melt will also change due to changes in the absorption of solar radiation and the water temperatures below it and the air temperatures above it, and then the carbon dioxide levels as well. And lastly, the depth and volume of lakes will likely change due to different precipitation and evaporation rates due to those warming temperatures. And these are my references. Thank you for listening to my presentation.